Einstein might be erasing entire worlds. Why two sun planets are missing Milky Way friends. Imagine this for a second. You're standing on a distant planet, and instead of one sunset, you watch two suns dipping below the horizon at the same time. Sounds like pure science fiction, right? But here's the twist. According to everything we know about the universe, these kinds of planets should be everywhere. And yet they're not. Something is removing them. And the surprising suspect? Einstein. Rocket shooting star, the cosmic mystery no one expected. Let's start with the numbers. Scientists have discovered over 6,000 confirmed exoplanets. Thousands of binary star systems exist, but only 14 planets have been found orbiting two stars. Think about that. Back-end index pointing right. Based on current models, we should have found hundreds back-end index pointing right. Instead, we barely found a handful. That's not just rare. That's a massive gap in our understanding of the universe. So where are all the Tatooine-like worlds? Ring planet. How binary star systems actually work. To understand the problem, let's simplify things. In a binary star system, two stars orbit around each other. A planet, if it exists, orbits both of them. Sounds stable enough, but it's not. Because that planet is constantly being pulled by one star on one side, another star on the opposite side. This creates a gravitational tug of war. As a result, the planet's orbit doesn't stay fixed. It slowly shifts and rotates. Over time, scientists call this motion precession. Balance scale, where Einstein enters the story. Here's where things get really interesting. According to Einstein's general relativity, massive objects bend space-time. This bending affects how objects move in binary systems. The two stars gradually move closer together over millions of years. As they do, their motion becomes faster and more extreme. Their gravitational influence changes in subtle but powerful ways. Now here's the key moment. Back-end index pointing right. The motion of the stars and the motion of the planet can sync up. This is called resonance. Collision, the breaking point. Orbital resonance. When resonance happens, everything changes. The planet's orbit becomes stretched, turns highly unstable, loses its balance. From here, two dramatic outcomes are possible. 1. Destruction. Fire. The planet gets too close to one of the stars. It is torn apart or swallowed. 2. Ejection. Milky Way. The planet is flung out of the system. It becomes a rogue planet, drifting alone in space. Either way. Back-end index pointing right. The planet is gone. New moon. The planet desert phenomenon. One of the most shocking discoveries from this research is something scientists call a planetary desert. Here's what it means. In binary systems where stars orbit each other in less than 7 days, back-end index pointing right, 0 planets have been found. Yes. 0. This is exactly where we expected to find the most planets. Instead, we find nothing. Telescope, why haven't we seen more? You might be thinking, maybe the planets are there, we just can't see them. And you're partially right, because the surviving planets tend to orbit much farther away. Our current detection methods rely on tiny dips in starlight. So if a planet is too far, back-end index pointing right, it becomes incredibly difficult to detect. Meaning, back-end index pointing right, there could be hidden planets, but not where we expected them. Bar chart, the numbers don't lie. Let's break it down. Around 10% of sun-like stars have giant planets. Binary systems should show similar numbers. Expected 300 planets observed. 14 confirmed. That's a gap of more than 95%. This isn't a coincidence. This is a pattern. Brain, what's actually happening physically? This process unfolds over millions, even billions of years. The stars start far apart. Gas and gravitational interactions pull them closer. Their orbits shrink. Relativistic effects become stronger. The planet's orbit destabilizes. Final step. Back-end index pointing right. The system cleans itself. Planets either fall in or get thrown out. Globe showing Europe, Africa, a familiar clue. Mercury, here's something fascinating. This isn't the first time Einstein's theory has solved a mystery. Mercury's orbit didn't match predictions.